Hello guys, in this video I'm going to be talking about the chord and segments of a circle. Looking at the diagram that we have below, the line AB is known as the chord and the shaded area right there is known as the minor segment, and this larger part here is known as the major segment. The area of a circle cut off by this chord is known as the segment, and then the line from the center of circle to the midpoint of a chord, it bisects the chord at right angles is what we have right here. This is the right angle that we're talking about. So it bisects the angle subtended by the chord at the center of the circle. These are the basics of a chord and segment. I'm going to do a couple of examples. Example number 1, we have been given a diagram and we're told XY is a chord length 12 centimeters. R, which is the radius, is 10 centimeters with center O, and we're asked to find part A, the angle XOY, which is XOY, which is this angle right here, and B, the area of the minor segment cut off by the chord XY. We're going to be finding this minor segment area. To find the angle XOY, I'm going to quickly sketch the triangle that we have. This is the triangle that we have. It's not really up to scale. So the radius, we're told that it is 10. So this side and this side, they are the same since it is the radius. And then the line XY, we're told that it is 12 centimeters. Hence, this is 6 centimeters and the other side is also 6 centimeters. And what we want to find is theta. So we're going to take this side or this side, either one works. If we're considering this angle right here, that means this is our opposite side, and then we have our angle. This is our hypotenuse. So we have our opposite and our hypotenuse. Hence, we're going to use sine. We know that sine theta is equal to opposite over hypotenuse. Hence, sine theta is equal to 6, which is our opposite, over our hypotenuse, which is 10. To get theta, we're going to punch this on our calculator, 6 over 10, and we get our answer correct to 2 decimal places as 36.87 degrees. But now, remember, the answer that we got is for this part only. So this part and this part, they are the same. Hence, to get the angle XOY, we're going to say the answer that we got for theta, 36.87 times 2. And our answer is 73.74 degrees. This is the angle for X or Y, and it's much more accurate if we put it to 1 decimal place. That is 73.7 degrees. That is the angle X or Y. We're going to move on to find the area of the minor segment cut off by the chord XY. The area of the minor segment is given by, we're going to say the area of the sector XOY minus the area of the triangle, and the area of the sector is theta over 360 times pi r squared minus the area of our triangle is half AB sine theta. And then we get 73.74 all over 360 times pi times our radius is 10 squared, this minus half. Our A is 10, our B is 10, and then sine, we're going to use it correct to 2 decimal places, 74. From this we get 64.35 minus 48. The final answer that we get is 16.35 square centimeters. That is how we find the area of the minor segment cut off by the chord XY. Moving on to the second example, example number 2, we are asked to find the shaded area when the radius is equal to 6 centimeters and theta is equal to 70 degrees. So again, quickly sketch the triangle that we have, and this is our theta, which we're told is equal to 70 degrees. So now, if we cut this then this side of the triangle will be equal to 35 degrees, and then our R is 6 centimeters, same as this side, which is 6 centimeters. And what we want to find is this part, which I will call X. So using this one side, this is the opposite. I'm going to look for this part. I'll still call it X. This is the opposite. This is the hypotenuse, and this is the adjacent. We'll say sine theta is equal to opposite over hypotenuse. That is sine 35 degrees is equal to the opposite, which is X that I'm trying to find, over the hypotenuse is 6. So to find our opposite, we say 6 multiplied by sine 35, and we get our answer as 3.44 centimeters. The whole X, which is from this point to this point, we are going to say X is equal to 2 times 3.44 centimeters, and we get our answer as 6.88 centimeters. That is the length of this X. To find the shaded area, we are going to say area of the sector minus the area of the triangle. And from the formula, we say 70 over 360 times pi r squared, and we subtract half a b sine 70. And if we punch this, we get 7 pi minus 16.91, which is equal to 5.08 square centimeters. Moving on to number 3, we are asked to find theta and the shaded area where AB is equal to 10 centimeters and our R radius is also equal to 10 centimeters. So I'll quickly sketch the triangle that we have, and we are told this is 10 centimeters, this is also 10 centimeters because it's the radius, and AB, which is this, is also 10 centimeters. So we have our angle theta, and if we do this, we remain with the right-angled triangle, and this side would be 5 centimeters. To find our angle, we say sine theta is equal to, our opposite is 5 over our hypotenuse, which is 10. And to find theta, we then punch this on our calculator, and that would give us theta is equal to 30. But remember, our 30 is for this part only. So to find the entire theta right here, we say theta is equal to 30 times 2, and we get 60 degrees. Now moving on to finding the shaded area. We already have the angle. So to find the shaded area, we're going to say the area of the sector minus the area of the triangle. And we get 60 over 360 times pi times the radius is 10 squared, and we subtract half times our A is 10, our B is 10 times sine 60. We get fractions 16 and 2 over 3 pi minus 25 root 3, and the final answer correct to 2 decimal places is 9.06 square centimeters. This is the area of the shaded region. Moving on to the last example, number 4. An equilateral triangle is inscribed in a circle of radius 10 centimeters. Find A, the area of the triangle, and B, we're going to find the area shaded. We know that equilateral triangles have the same size length and they also have the same angle. We know that these are the same, the sides are the same, and the angles are also the same. That is 60 degrees, 60 degrees, and this is 60 degrees, adding up to 180. We can sketch this and say, okay, this is the circle that we have, and we have our center as center O. So we have something like this. This is a sketch, guys. Right, we have something like this. These angles are going to be 120, this is 120, and this is also 120. They have to add up to 360 degrees. And we now know that OA, okay, we had A, B, and C. OA is equal to OB, and it is also equal to OC, and they are all 10 centimeters. And similarly also, the angle AOC is equal to the angle AOB, and also equal to the angle BOC. To find the area of the triangle, that's the area of ABC, we're going to find the area of triangle AOB, and we're going to add the area of triangle AOC, and we're also going to add the area of the triangle BOC. Because AOB, AOC, and BOC are the same parameters, I'm simply going to find the area of one triangle, then I'll multiply it by 3. The area of triangle AOB is equal to half AB sine theta. Half multiplied by 10, multiplied by 10, multiplied by sine theta is 120 degrees, and from this we get 25 root 3. This is for one triangle, and since they are 3, I'm going to multiply this by 3, and we get the answer as 75 root 3, which is equal to 129.9 square centimeters. That is the area of the triangle ABC. Moving on to finding the area shaded, I'm going to say the area shaded is equal to the area of the circle minus the area of the triangle that we just found. So the area of the circle is found by saying pi r squared minus the area of the triangle that we just got. Pi r squared is pi, the radius is 10, minus the area of the triangle was 75 root 3. So we have 100 pi minus 75 root 3, and we get 184.26. Rounding it off to one decimal place, we get 184.3 square centimeters. So that is how we solve this question above. Do not forget to hit the subscribe button, guys. I'll see you in the next video.